here we go. Lively filament model. Well, I keep talking about the sarcomere, and here's what I want to do now. We're going to turn this off, and we're going to use our, well, you guys can sort of use this, and I'll be talking on the board. Okay. I kind of sort of talked about this when we started class, and we were talking about the plasma membrane. So now we're going to actually see this and sort of what's going to be happening with the muscle contraction. So let's go back to our visual that we had then, where let's say this is our nerve coming in. Now, my plasma membrane, this is going to be my muscle cell. Because remember, the nerve is entering only at one point of that cell, that fiber, okay? So, if I have this one long cell, one long fiber, what I'm going to find is that it's going to be made up of a sarcomere. Okay? So this sarcomere, it goes all the way down the muscle. Okay? Keeps going for the length of the muscle. Sarcomere after sarcomere after sarcomere after sarcomere. Then, what I'm going to find is that I've got the thick filament, the myosin, and then that myosin is surrounded by the actin. Okay, you're going to follow me. All right, so from one end of the sarcomere to the other, the border is my zygote. Okay? I've got some little chitins that's present, that little protein that I mentioned. And in order, if I have this structure going all the way down, okay, so if I've got this structure going all the way down the length of my muscle, okay, and sarcomere after sarcomere, in order for this to be contraction, these are going to have to shorten. So, here we are. Okay? We have our higher order thinking skills. Alright? And we're going to want to make sure that I get movement to my leg and my lower body. Okay? So that when it's time to go, we get to go. Alright? So up here in my brain, I got this stuff happening because I'm thinking, and then that's going to send an impulse down my spinal cord, out by way of my spinal nerves, which are going to make it to this nerve that's meeting my muscle fiber. In this situation, okay, between the nerve and the muscle, this is called a neuromuscular junction. Have you heard of that before? No? You will, because certain things that can go clinically wrong, they will say at the neuromuscular junction, blah, blah, blah. Okay? So, when we look at the structure of this neuromuscular junction, this area in between the nerve and the muscle, this area is called a synapse. Now this nerve that's meeting this muscle cell, that's coming from my spinal nerve, that is exiting out from my spinal cord, okay? Do you guys remember the structure of a neuron? Alright, so for the most part, they're not all like this, but for the most part, when we think of a nerve cell, we tend to think of a huge nerve cell body with a really big nucleus. We've still got endoplasmic reticulum, blah, blah, blah. Alright, we've got the dendrite, we've got a long axon, and then the terminal end. Okay, is everybody familiar with that? So over here, where we are thinking about getting out and passing that information down our spinal cord, in our spinal cord, we're going to find that huge nerve cell body with the little dendrite, because they got to make a connection up here to the big areas of the brain. But then that information is going to exit, make its way to here. Because my nerve, don't y'all love telling somebody? Okay? And as we learn the nerve, y'all get to hear the name of one. Okay? Now, right now, you can go out and say, you know what, you just on my last spinal nerve. Okay, see what happens. It'll be fun. Now, up here in the body of that nerve, this is still a cell, which means it has to make its product. And in this case, the product, the only thing a cell can make is what? Y'all know this. A protein, okay? So it's got to make protein, and in this case, because it's a nerve, it's making a protein that we're going to know as the neurotransmitter. Alright, the product of a nerve is a neurotransmitter. It just becomes which neurotransmitter. Okay? So, in this case, for skeletal muscles, alright, the little protein that's going to get made and is going to travel the length of my axon and then be in little vesicles down here at the end of that nerve. In this case, this is called acetylcholine. The neurotransmitter for muscle contraction is acetylcholine. So, my product, the ACH, that's been made by the nerve, it's just simply waiting for an impulse so that the nerve can release it into the synaptic cleft. Is everybody following me? Now, when I get my impulse, my stimulus, okay, that acetylcholine, these little vesicles, will fuse and release this acetylcholine into the synapse. Now, based on what we now know about the structure of the plasma membrane, what do I find embedded in my plasma membrane? Protein. Now, some have to act as a receptor. Because my nerve is only going to be found at this one point, there are going to be a ton of proteins present that are going to be receptor proteins. Are they going to be gated or non-gated? They're going to be gated. So, when the acetylcholine gets released, the receptors will accept the acetylcholine. And if they accept the acetylcholine, what happens to the gate? The gate opens. If the gate opens, what rushes in? Not sodium. Because on the outside of a plasma membrane, sodium is always in high amounts. Okay? So now, sodiums get to rush in. When they rush in, what did we say was making a little indentation all the way down that muscle fiber? T tubules, T for transverse going through, okay? The T tubules, all right? And if the sodium goes down those T tubules and encounters the sarcoplasmic reticulum, and that activates the sarcoplasmic reticulum, what gets released from the sarcoplasmic reticulum? My calcium. Is everybody seeing where I'm going with this now? So, if my sodium came in, if it hit the T tubule, if it made it to the sarcoplasmic reticulum, and things get going, calcium got released. To make sure that this occurs all the way down, what other types of proteins do I have embedded in my plasma membrane? Zach?
Would it be non-gated?
Well, I've got non-gated that are going to be present. So which kind? My voltage gated. All right. So if I've got some of my voltage gated that are, note, they are not in the area of the synapse. Okay? What